Welcome to skill video number 203 for AP Calculus BC. I can evaluate composite functions and transform functions algebraically and graphically. Welcome to skill video 203. We'll start our notes on 203A. First, we're going to talk about evaluating composite functions, and this is a skill that we should have practiced from Algebra 2 and pre-calculus, so I will move fairly fast through it. An example, given if we have f of x and g of x, evaluate f of g of 3. And so this is your most basic form of a composite function. And so what this is saying is evaluate f at g of 3. So we need to evaluate what is g of 3. So we plug 3 into our g function. We get the absolute value of 3 plus 3, which is 6. So we're evaluating f of 6, which means plug 6 into the f equation. 2 times 6 squared minus 1. We get 36 times 2 is 72, minus 1 is 71. Then in part B I said let's evaluate g of f of 3. And the big purpose of this was to show that if we were to do that, we may not necessarily arrive at the same answer. So f of g of x does not necessarily mean g of f of x, and we should be careful that we don't make that mistake. And then we can also evaluate it for the variable. So part C I did instead of plugging a number in, I plugged the variable into it. So let's shrink this. F of g of x means we're going to take the whole function of g and plug it into our f. So we have 2 times the quantity of the absolute value of 3 plus x squared minus 1. And if we square an absolute value, the absolute value kind of cancels itself out, and so I went through the process of simplifying it down into a polynomial here. Part D, evaluate g of f of x, and I did the same process here with the absolute value, and regardless of what value we plug in for x, as long as we're in the real numbers domain, the absolute value actually self-cancels. And you won't find that always to be the case, but it happened on these two problems, largely because the square of any number is positive. Example 2 is a more difficult example, and it's more in line with what you might find on the Khan Academy website. So what they give us is g of t is 4t cubed plus 6t squared plus 5t plus 2 minus 3 times the function of t. And then f of n is negative 6n squared. And they're asking us to find g of f of 0. So first we need to find f of 0. So we plug in 0 and we get, I should have written this down, but f of 0 is negative 6 times 0 squared, which is equal to 0. And we plug that in for f of 0. So what we're evaluating is g of 0. So we go back up to our g function and we plug in 0 for our variable. So we get 4 0 cubed plus 6 0 squared plus 5 0 plus 2 minus 3 times f of 0. And we have to again go back and evaluate what is f of 0. Well, we already know f of 0 is 0. So we have 2 minus 3 times 0, which is 2. That's another sort of composite function where you have a function within the definition of the whole function. So, all right, the second part of the skill is transforming functions algebraically. And I went over this a little bit in skill 202, but some common transformations that we have: vertical translation when we're moving a function up or down, and that looks like function plus k, and that means move up k units. A horizontal translation would be f of x minus h, which means move h units right. For example, if we had x minus 2 squared, that'd be taking the parabola and moving it to the right 2 units. Whereas if we had x plus 7 to the third, that would be taking the cubic and moving it 7 units left. The vertical stretch or compression, we multiply the whole function by a value. And the size of that value determines what sort of thing's going on. If the value a is between 0 and 1, it's a vertical compression. And if it's greater than 1, it's a vertical stretch. So 3 times x squared is a vertical stretch, whereas 2/7 times x to the third is a vertical compression. If it were negative, then you're talking about a mirror or a flip, so we'll talk about that in a short bit. Horizontal stretch or compression, we take the x value and multiply it by 1 over b. So if b is between 0 and 1, then it's a horizontal compression. Oops, that's a typo. That should say stretch. And the one below it should be compression. Okay, so if b is between 0 and 1, then it is a horizontal stretch. For example, if you had 1/3 of x to the third power, that is stretching by a factor of 3, as opposed to 5 over 1 x quantity to the fourth. That's going to be compressing it by 1/5. And this is easily the most difficult one to remember. I think the easiest way to think about it is to take the reciprocal of the number in front of x, and that'll tell you what's going on. So the reciprocal of 1/3 is 3, so it's getting 3 times as big. The reciprocal of 5 is 1/5, so it's getting 1/5 the size. All right, moving on to mirroring. If you switch x with negative x, what you're doing is you're mirroring it over the y-axis. It's a horizontal flip. And then if you put a negative in front of the f of x, it is a vertical flip. So we're going to look at a few algebraic examples, and then we'll look at some graphical examples. All right, example 3. What we're given is a function, x squared plus 2x minus 5, and that is a quadratic trinomial. And I'm doing different sorts of transformations to it. So in part A, shift the function 3 units to the right. That means take all of the x's and replace it with x minus 3. And that'll move you 3 units to the right. From there, I did the whole process of factoring it and then condensing it back into a trinomial. Part B, shift the function 1 unit down. So if we take the whole function and we shift it down 1 unit. This is a much easier piece to simplify out. What we get is x squared plus 2x minus 6. A reflection over the y-axis means take all of the x's and make them negative x's. So we take x, replace it with negative x, take the other x, replace it with negative x, and then you simplify it. The horizontal stretch by a factor of 3 means take all of the x's and replace them with 1/3 x. And that'll horizontally stretch it by 3. So we plug in 1/3 x, and we distribute the square, and we get x squared over 9 plus 2/3 x minus 5. If we want to vertically compress the whole function by, we'll say, 1/5, what we're doing is we're taking the whole function and multiplying it by 1/5, which gives us x squared over 5 plus 2x over 5 minus 1. And finally, in part F, we're doing two transformations. First, we reflect over the x-axis, then we shift up 4 units. So here's our original function, and by plugging a negative in front of it, that is going to reflect it over the x-axis. I distribute that negative, and then I'm going to take that function, that first transformed function, and I'm going to shift it up 4 units. So I have the function, add 4 to the end, and get a simplified answer. Something that I encourage you to experiment is to see if this transformation would yield the same answer if you first shifted it up and then reflected it over the x-axis. All right, finally on page 203D, what we have is transforming functions graphically. We have 2 pieces. We should be able to look at a transformed function and identify the transformation with an equation, and then we should also be able to transform a graphed function. So the examples I give you are pretty rudimentary because I just want to briefly touch on this. So what we have here is it appears to be an absolute value function. I told you that the vertex was at 2, -1. So we have the absolute value of x, and it's been shifted right 2 units and then down 1 unit. In the second example, we have what looks like a cubic, and that crosses at the value of 3. However, we should remember that cubics actually start low and finish high, so this has been, looks like, reflected over the x-axis. One possible way that we can look at this is first we take our function and we flip it, and that's going to flip it over the x-axis, and then we take it and shift it to the right 3 units. So you can also look at it as a horizontal translation and then a flip. I think this one's easier to understand when I look back at my work. So either one makes the same answer, however. So it's a fun exploration to plug it into a calculator if you want to see what's going on. Usually the horizontal translations and flips get a little difficult to manage because you're doing 2 things that order may come into effect. So you have to be careful with those. All right, finally in the third example, what we have is a parabola that has been shifted to the right 5 units. And then I added this second point in here because we should know that with a parabola, when we start, we're going to go out 1, up 1 to make our first point. And in this case, it looks like we've gone out 1, up 2. So there's been a vertical stretch by a factor of 2. So we've got the x plus 5 moving us to the left 5 units, and then we stretch it by a factor of 2. For the skill test, I will try to make all things about this level of difficulty. I won't get more complicated. So this is actually a really easy example to see what's going on. Finally, we should be able to transform a graphed function. So I've got that going on down at the bottom of the page. My first function that I've drawn is a piecewise function. And for the curious, this looks like negative square root of x. This looks like y equals x, and this looks like y equals 2, though I have no vertical axis. They just asked us to vertically compress it by 1/2, so I used the lines of the paper to help guide me. I was at a height of 2, so I switched it to a height of 1, and then 0 goes all the way up to 1/2, and then the root function is compressed in half. Next one is a upside down parabola, and it says horizontally shift left 1 and then reflect over the y-axis. So the first thing I did was I shifted it to the left one, so it looked something like that, and then I reflected it, giving me the result here. This is another one of the examples where doing it in the reverse order would have resulted in a different value or a different graph, which I'll show you below. If we have our function and we first reflect it over the y-axis, we'll get that, and then we shift it 1 unit left, we'll get further away from the axis. So you can see that here I'm 3 units away from the axis as opposed to 1 unit away from the axis. So you got to take attention to the order that they're listed when you're given 2 shifts. All right, that concludes a longer video. Sorry, this was a long one. Hopefully most all of this is a review for you at this point. All right, this concludes video for skill number 203. I can evaluate composite functions and transform functions algebraically and graphically. Thanks for watching.